In this video, I'm going to show you a couple of examples involving exponential functions. Okay, we're going to find the exponential function that passes through the points 0, 2, and negative 2, 18. So we start with the general form of an exponential function. If this function passes through the point 0, 2, that means that when x is equal to 0, y is equal to 2. And if it passes through the point negative 2, 18, then when x is negative 2, y is 18. So we can set up one equation by plugging 0 in for x and 2 in for y. And we can set up another equation by plugging 18 in for y and negative 2 in for x. Okay, let's simplify the first equation. We have 2 equals a times b to the 0. Well, b raised to the power of 0 is just 1. So this thing becomes 2 equals a times 1, which says that 2 is equal to a, or a is equal to 2. Using this value of a, we can plug it into that equation, and then we have the equation with just b in it. So that's 18 equals 2 times b to the negative 2. b to the negative 2 is 1 divided by b squared. 2 times 1 divided by b squared is just 2 divided by b squared. Okay, to solve this, we'll multiply b squared to both sides, so we get 18 b squared. 2 divided by b squared times b squared is just 2. So here we have 18b squared is 2, so b squared is 2 divided by 18. 2 divided by 18 is 1 divided by 9. So b squared is equal to 1 divided by b. If we solve that for b, we're looking for what we square and get 1/9. So that says that b could be 1/3 or negative 1/3. However, in this case, b is the base in an exponential function. We know the base cannot be negative, so that one is out, and b is 1/3. So here, y equals a times b to the x. We found that a is 2 and b is 1/3. So this right here is our answer. Okay, in this example, I would like to sketch the graph of y equals 3 times e raised to the 2 minus 3x. I like to work with exponents when the x is written first, so I'm going to rewrite this. Okay, so here we have the parent function is y equals e to the x. So to get the graph of y equals 3 times e to the negative 3x plus 2, I'm going to do a series of transformations to this one. The first thing that I'm going to do is move left 2 units, and that's because of the plus 2 here. The next thing that I'm going to do is take care of the 3 in front of the x. So x is being multiplied by 3, so we're going to have a horizontal shrink by a factor of 1/3. Next, I'll take care of the negative sign that is right next to the x. That's going to be a y-axis reflection. Okay, finally, I'll take care of the 3 that's being multiplied by all of this. That is a vertical stretch by a factor of 3. Okay, so let's start by plotting 3 points on the graph of the parent function. When x is equal to 0, I get e to the 0, and that's just 1. So here I have the point 0, 1. When x is 1, I get e to the 1, which is just e, and that's around, I'll just use 2.7 for this purpose. So 1 around e, or e, which is around 2.7. And when x is negative 1, we get e to the negative 1, which is 1 divided by e. Okay, so we'll plot that around 1/3. So that's the point, negative 1, 1 divided by e. Okay, so this is an exponential growth function. It goes like that. Okay, so now I'm going to do all 4 of these transformations to each one of these 3 points. So we'll start with 1, e. So if we shift left 2 units, that means we subtract 2 from 1. So that's going to take us to -1. Same y-coordinate. Then we do a horizontal shrink by a factor of 1/3. That means the x-coordinate gets multiplied by 1/3. Then we do a y-axis reflection, so the x-coordinate gets multiplied by -1. And then we do a vertical stretch by a factor of 3. So that means the y-coordinate gets multiplied by 3. Okay, why don't you press pause while you work on the transformations for 0, 1, and -1, 1 over e. Okay, so the point 0, 1 goes to -2, 1 when we shift left by 2, -2/3, 1 when we do a horizontal shrink by a factor of 3, then 2/3, 1 after the y-axis reflection, and 2/3, 3 after the vertical stretch. Okay, similarly, the point -1, 1 over e goes to the point 1, 3 over e. Okay, now we need to plot these points. So we have the point 1/3, x is 1/3, and the y-coordinate is 3e. 3 times 2.7, that's a little bit over 8. So we have 1, 2, 3. So we have the point 1/3, 3e, which is right around there. And then we have the point 2/3, 3. And we have the point 1, 3 over e. 3 over e, that's a little bit over 1. Okay, and for a parent function, the x-axis is a horizontal asymptote. Since we don't have a vertical shift, that horizontal asymptote won't move. Okay, so we still have the x-axis as a horizontal asymptote. Once again, the only way that your exponential function that you're graphing, the transformation of it, the only way it's going to move the horizontal asymptote is if you do a vertical shift. Okay, so we just connect these dots here. Okay, so this exponential function is super steep between x equals 0 and x equals 1. So we can find the y-intercept by plugging 0 in for x. So we get y equals 3 times e raised to the -3 times 0, that's just 0, plus 2. So 3e squared, and 3e squared is, it's just close to 22. Okay, so the y-intercept way up here, can't see it, the y-intercept way up there would be the point 0, 3e squared, which I said is around 22. There's no x-intercept because there's nothing we can plug in for x here and get 0 as our answer.